All right, welcome geometry students. So you should be looking at Unit 1 Topic 4 packet. Not all of my slides correspond with the packet, so you are going to need to either get some scratch paper and work through some problems with me, or just follow along. All right, but there are many pages. We're just going to focus on pages 1 through 16 in this packet. Let's see, we need this guy out. Okay. So, if you'll turn to the first page, your page looks like this one. But I'm going to use this other page which has a little bit more to it. Okay, so if A equals B, then A plus C equals B plus C. And this is a certain property of equality. And what we call that first property of equality is the addition property of equality. All right, the addition property of equality states that we can add the same thing to both sides. Like I could say, let me add 3 to both sides. So here we get x equals 13. All right, so your property is going to be addition property of equality. You're going to next write in the subtraction property of equality. Like if we have an equation, we can subtract the same thing from both sides and it's still a true statement. If I subtract 5, we get 18. So we can solve an equation algebraically using the subtraction property of equality as long as we do the same thing. And when we say to both sides, we're talking about both sides of the equal sign. You guys probably already know that, just trying to clarify here. All right, then we have multiplication property of equality, right? If we multiply the same number on both sides, we still have a true statement. So if we want to undo division, like here, divided by 6, we could multiply by 6 and find out what x equals. Okay, so multiplication property of equality. The next one, division property of equality. If we want to undo multiplication, we can divide both sides of the equation by the same number and get our answer. All right. Notice we are not dividing by 0. Here I have c is not allowed to equal 0. Let's see if yours says that. If it doesn't, let's add it in. For division property of equality, let's go ahead and state c is not allowed to equal 0. C cannot equal 0 because we cannot divide by 0. All right. I think I have an extra property in here. You go straight to the reflexive property, A equals A. Pretty obvious, right? Reflexive property, if A equals A, if something equals itself, we call that reflexive property. And these are going to be reasons when we're talking about our proofs. We've got a statement and a reason, and the reason is going to be reflexive property. So we need to familiarize ourselves and get comfortable with these different properties. All right. So I have an extra one in here called substitution property, and that is if A equals B and A equals X, well, since A equals both B and X, then B equals X. That's called substitution property. I want to say that's also called transitive property. So I feel like substitution property and transitive property are very similar. If A equals B and B equals C, then A equals C. We already kind of said that, right? That's the same concept. So I think the difference is substitution here, if A equals B and A equals X, I'm substituting in place of A, I'm substituting in X to get X equals B, right? So we're thinking about it as substituting. And here, we're saying, well, if one equals another and this equals A equals B and B equals C, then those two things must be equal since the B's are equal. Okay, and the last one we have for you is symmetric property. If A equals B, then B equals A. That it doesn't matter the order that you state the congruence. Now, I have to be careful with that because I just said the order doesn't matter. We have to be careful when we state like triangle congruence. Okay. When we're talking about triangle congruence, it's very important the order that we state our the way we name the triangle. Sorry. Okay. So if A equals B, then B equals A. What did we say that was called? A equals B, then B equals A is called symmetric. Okay, so you guys have symmetric property. A equals B, B equals C, then A equals C. That's substitution or transitive. This was symmetric, is that what we said? Symmetric. All right, and if A equals B, then either A or B can be substituted for the other in any equation or inequality. Because they are equal, we can substitute them in. Let's use substitution property. All right, and here it looks like we've got a distributive property. Distributive property. All right, so we're going to use these properties to start looking at proofs. Okay, so we have some kind of silly proofs that turns a dog into a cat. Okay, so we have a letter puzzle below, and you're going to move from the start to finish, and you're allowed to use these rules. Rule 1 says double O's can be changed to an A. Well, I don't have a double O, but I need to change my O to an A, so I need to get a double O. All right, any letters can be doubled. Oh, we could just double O. Any letter can be changed to a T. Oh, well, let's just change our G to a T. That would make sense. And a C can replace a pair of D's. Okay, so we're going to need to make a couple steps. And technically, it doesn't matter the order of those steps. Sometimes the order does matter. Some things must come before other things. But in this case, it doesn't really matter. All right, so we start. This is going to be our statement. And if we make a statement, we need to have a reason that we can make that statement, right? We want to have a valid argument. Why did you do what you did? Okay, so dog was given information. That's the reason we could write dog, because that's what was given. All right. So I'm going to first start with D-O-O-G. And what rule did I use? Any letter can be doubled. Okay, so we're going to say, using rule 2, I doubled the O. Okay. And then, if I double O's, can be changed to an A. So I'm going to change it to D-A-G. And I can change it to that because of rule number 1. All right, if you would like to pause and go ahead and do the next couple, if you get the gist of what's going on here, that's great. If you want to keep watching, that's great too. Feel free to fast forward to the end of this if you've got it. All right. So any letter can be changed to a T. I'm just going to take that G and change it to a T, because that's what it said. I can just change that letter to a T, and that was rule 3. And then I'm going to take my D, I need to double it. And doubling was for rule 2. And then a double, let's see, a pair of D's can be replaced by a C. Okay, and I could do that for what reason? Pair of D's by rule 4. Okay, and then we've got what we ended with. All right, so this actually would be our finish. That would be our last step. All right, so we just changed dog into cat with those 4 rules. All right, try this one. Try to change H into mama. All right, I think you have 2 more of those. If you want to hit pause, go ahead, take a minute, try that. So now we have one that's a little more math oriented. So we have a couple rules. 12 equals a dozen. And we know all of this should equal a dozen. Okay, so this is a little tricky to read. I think this says 2x equals 4, 5y equals 9, and z equals -1. And 12 equals a dozen. Okay, So I am going to add these two together and say 2x. Can we just say 5y plus z? Okay, I'm kind of doing a bad habit here because technically you want to have one step. Each line has one thing performed, but I'm gonna combine these two. Okay, so we added these two things together. So we're gonna call why were we able to do that? I'm gonna say combine like terms because it's not exactly addition property of equality because it's not an equation. We're not adding the same thing to both sides. We were just combining like terms. Okay, now I know 2x equals 4. So I'm going to replace that with a 4. And that was rule 1. And then I'm going to replace 5y with a 9. And that would be rule 2. And 9 plus 4 is 13. Let's just say addition property. By addition. Alright, and then z is -1 by rule 3. Add those together. I can add them together, I just use addition. Alright, but how did I get from 12 to a dozen? I used this rule 4. So every box needs to be filled in. I need to have a statement and a reason. Okay, even at the very end, if you finish with a dozen, you need to say why were you able to take that last leap to get to your final answer. Okay, so what this is a 2-column proof. We are showing you examples of a 2-column proof. Okay, we're working our way into it. So this is where it starts to not be in your packet. So if you want to get out some blank paper, that would be great. You can, let's check this out. Okay, so here's an example of a 2-column proof. We're using algebraic properties and reasonings to prove that x is 10. Okay, so we have our statement. We start with what's given. We give the statement, and our reason for writing that is it's given. We know that's true because it's given. All right, and then we can start doing some math. We can say, well, I would like to add 7 to both sides. If I add 7 here, that cancels, and I get 4x. 2x. If I add 7 here, we get 20. Okay, so we added 7 to both sides, so we're going to say addition property of equality. I'm going to use some abbreviation. Okay, great. Now I think I'm going to subtract 2x from both sides. If I subtract 2x from both sides, I get 2x equals 20. So I use subtraction. Property, property of equality. Okay, and the last step, it looks like we need to divide both sides by 2, so we used division property. Oh my goodness, what is going on with my spelling today? Huh. Division. Alright, let's try that again. Okay. Division property of equality. Okay, great. So that is our 2-column proof. Let's look at a flowchart proof. So you will have the option to choose between a 2-column proof, a flowchart proof. Those are really the two that we would use the most. We more focus on 2-column proofs, just so you know. Okay, so flowchart proof looks like this. Like we start here, and here's the statement, and here's the reason. So we have statement and reason banked down here. So the statement we would start with is what was given. If this is true, then x equals 12. So that's what we need to end with, and that's what we need to start with. I don't feel like I have enough steps here. Okay, so this is what we started with, and it was the given equation. All right, and then with subtraction property of equality, we subtract 16 from both sides, and we end up with this. And in order to get from here to here, we used subtraction property of equality. Please don't use such abbreviation that you would write sub, because there's also substitution property, so subtraction, we really need to write it out. Okay, so subtraction property of equality got us from here to there, and then to get from here to here, what do we do to both sides? We divided. Yep, divided by 12, and we got x equals 12, so we put that in. We used that already. Use that, and division property of equality. Okay, we already knew that. Divide both sides. Division property of equality. All right, so that is an example of a flowchart proof. It's just kind of in a different direction, uses arrows. All right, so there are a couple flowchart proofs for you to practice. I'm not giving you the reasons. You want to work them through yourselves. This one's interesting. It gives you parts in the middle, but other parts you have to figure out. All right, so please try that page on, oh, you don't have that page, do you? Okay, All right, these are 3 problems. I will zoom in so you can see them better in case they're blurry. They're blurry here. I'm not sure if, hope they're not blurry at home. Okay, so if 3x divided by 4 equals 24, then x equals 32. If you will please do a flowchart proof for that on a piece of paper. And we have 5x minus 21 equals 54, then x equals 15. Go ahead and do a flowchart proof on a piece of paper. And the last one, 2 times the quantity, x minus 1 equals 100, then x equals 51. So those 3 problems, I would like you to do a flowchart proof, take a picture and send that to me. Okay, or upload that. All right. So now we're going to do some more 2-column proofs. All right. Okay, so we have a little less given, and now we are going to do the whole thing. Okay, so it's what's given goes first, and the reason we write it is given. We know this is what we started with. And like with math, sometimes, you know, you might take this as your first step or that as your first step. We definitely want to distribute that 2 in there. So we're going to go 2x plus 8 equals 5x minus 1, and we use distributive property. Okay, next step, I'm going to subtract 2x from both sides. Subtraction property of equality. All right, I'm going to add 1 to both sides. Addition property of equality. All right, and last step, divide by 3. Division property of equality. And that's what I was supposed to prove. That was my endpoint. I didn't know where the endpoint should go, so I wasn't going to write it in first. Should it go here or there? It just kind of got me there. All right? You guys try this one. Go ahead and pause. Make sure you got it. All right, that's what that one would look like. So we used given, addition property of equality, and multiplication property of equality. All right. So again, you do not have this on your papers. This might be something good to write down. It says list all 5 ways we can prove triangles are congruent. Okay, and Monday in class, you watched a video and practiced each of these ways. The 5 ways are the song, right, with the video, side, side, side. Oh, if I forgot the song, I need to watch the video again. Side, angle, side, angle, 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 side. Okay, and the hypotenuse leg. The ones that are not allowed are side, side, angle, and angle, angle for triangle congruence. Okay, introduction to congruent triangle proofs. So, we're going to mark the triangles based on the given information. Make a plan. How am I going to prove this triangle is congruent? You want to know that before you start. And then start proving. Make sure you've proved all necessary sides and angles before, based on what your plan is. Okay. So, I'm sorry about that. What is that even saying? AB is parallel. Okay, this mark right here should have been AB is parallel to DC. Sorry about that. The computer came out kind of blurry. Okay, so we are going to identify that AB is parallel to DC. We're going to mark this information on here. Okay, we also know that AB is congruent to DC. All right, so that's a different mark, right? That's parallel and that's congruent, so they're the same length. And we need to prove that ABC is congruent to triangle CDA. Okay, so that's our last statement. If we're proving it, that's our last statement. And we start with this statement. So I'm giving you the statements, and we need to figure out what are the reasons that we can walk through those steps. So, well, AB is congruent to DC because that's a given statement. I know that that was given. Okay. Also, these two are parallel. That's also a given statement. All right. Sometimes people write both givens on the same line. Sometimes you write it separate. Either way is fine. Okay. Now here, we are going to say that angle BAC is congruent to DCA. BAC is congruent to DCA. And this is a transversal, parallel lines cut by a transversal. We haven't done this yet. We're going to do this after Thursday or on Thursday, but those angles are called alternate interior angles. So the reason we're giving is alternate interior angles. Okay. AC is congruent to AC. Well, if AC is congruent to itself, right, this line AC is congruent to itself. Sometimes you'll see this. It's like an X. This is congruent to itself. Well, the property we're going to use is called the reflexive property. We talked about that a minute ago. A equals A, right? If something equals itself, it's called the reflexive property. All right. So here it already kind of gave us a plan, but if I know that this side is congruent to that side, and this angle is congruent to that angle, and that side is congruent to that side, we've got side, angle, side, right? Side, angle, side. All right, so we know that those two triangles are congruent because of side, angle, side. All right. Let's try another. So here it's giving us just a little bit less information. Another property that I want to share with you is this property called vertical angles. If you have two lines that are intersecting lines, this angle and this angle are called vertical angles. All right, and they are equal. Two intersecting lines have these vertical angles that are equal. This angle is equal to that. This angle is equal to that. All right. So if we are given the angle S is congruent to angle T. Angle S is congruent to angle T. Angle S is congruent to angle T, and that is given. All right. We also know V is the midpoint of RU. V is the midpoint of RU, which means this is halfway between R and U, but it did not say that it was halfway between S and T, so we cannot assume that. All right. All right, so it's given that, notice V is the midpoint of RU, that's our other given statement. Notice how sometimes a given statement could be given a little bit later, like, well, let's use this angle, and then, oh, well, since I know that angle S and angle T are congruent, well, let me look at what else I know. TVU, this angle right here, is congruent to its vertical angle right here, T. Now I need to start at this sharper angle. Let's say SVR. Angle SVR. Technically, if you go in the other order, it's not going to hurt anything. But when we talk about triangle congruence, they have to be named in the same exact way. So I just want us to practice. If I'm going from this angle T to V to U, I'm going to start at S to V to R. Okay, so how do I know those angles are congruent? Because they are vertical angles. All right. RV, what is RV congruent to? Oh, we know because of the midpoint, we know that RV is congruent to UV. Line segment RV is congruent to line segment UV. All right, and we know that by definition of midpoint. By the definition of midpoint, the given statement, we know that it's halfway. So halfway means that each of those sections from the endpoint to the midpoint are going to be equal. All right. Now, what is it that we've shown? Here we've got an angle, another angle, and a side. Is that allowed? Angle, angle, side. Let me make sure it doesn't spell a bad word, right? Is that one of the ones I'm allowed to use? Yes, it is. All right. So I can prove that RSV, let's make sure the order, RSV is congruent to UTV. Notice how I went from this to this to that. Here we're starting here to that. I just want to make sure it's the same shape, RSV. So R corresponds to U, S corresponds to T, and V corresponds to itself. Great. So that is a true statement. And how do I know? Because of by angle, angle, side. All right. So that is a triangle congruence proof. I know we're still out of your, not in your packets yet. Okay, so I am trying to print this out today and get you copies. If that doesn't happen, I will get them to you on Thursday. But there's given is what's given. This is just a list of all the different properties that we could use. Reflexive property, when something is equal to itself. Transitive property, this is equal to that is equal to that, so this must equal that. All right, substitution property, definition of a linear pair. So if I know there's a straight line, and there's two angles that form that line, I know that they're going to sum to 180 because they're a linear pair. All right, definition of midpoint, we used that just a minute ago. If we know something that is the midpoint, then we know the two segments on either side of that midpoint are congruent. Complementary angles and supplementary angles. Complementary is sum to 90 degrees. Supplementary angles, sum to 180 degrees. All right, definition of bisector. Well, if something has been bisected, then it's been cut in half, and each of those angles are the same. So if we say something has been bisected in the given portion, then we know that those two angles that were formed are going to be equal. All right, definition of perpendicular line. Well, if I know that something is perpendicular, then I know it's right. And if I know it's right, definition of right, then I know it's 90 degrees. All right. So perpendicular right, 90. That one's a little tricky. So if I know it's perpendicular, then I know it's right. And if I know it's right, then I know it's 90 degrees. This one, a lot of people want to take a shortcut and just go perpendicular 90 degrees. technically we're supposed to go perpendicular. I know it's right, right. I know it's 90 degrees. All right. Definition of an isosceles triangle. It's used as a reason why two sides of an isosceles triangle are congruent. If we're informed that it's an isosceles triangle, well, these two sides are going to be congruent. Well, it doesn't have to be those two sides, but if they're marked, these two sides would be the two congruent sides. All right. Here, the base angles, and we're going to kind of work on the base angle theorem, but if these two sides are congruent, then these two angles must also be congruent. And we'll look more at that later. Okay, so we don't use every single one of these, but I just wanted to kind of expose you to them so that you have seen them. Okay, vertical angles, we talked about that a minute ago, where I give you, change to a pen, vertical angles, any vertical angles, this and this are equal. No matter how you draw it, these are always going to be equal. It's not just the right and left, right? So this angle here is congruent to this angle here. So let's put 2, 1, 2, 1, 2. All right, so those are vertical angles and they're going to be equal. Alternate interior angles. All right, so these ones, alternate interior, corresponding, same side interior. These ones I think we're going to go over in class today. Today's Monday that I'm making this video, so I will discuss those in class, okay, because we need to draw a picture to really explain those. All right, and then you can work backwards from each of those. Segment addition postulate, if you add two parts, it makes the whole. Angle addition, if you add two angles, it makes the whole. These are the reasons to use to describe why two triangles are congruent. All right, and the last one, CPCTC, corresponding parts of congruent triangles are congruent. That's to use to explain why a part of the triangle are congruent. All right, I have students wanting to come into class. Okay, so here are some triangle proof practice. Here, I can just see immediately what it is that we're going to use. I see side, angle, side. These sides correspond, these angles correspond, those sides correspond. Side, angle, side. So I know that my reason at the very end is going to be side, angle, side. But I need to go back and prove that. How? Okay, well, AB, I want to write out my givens. What do I know? I'm given all three things. If I want to write it all on the first line, that's great. It's given. I mean, oh my gosh, this is just 3 givens, right? Given, given, given. I didn't have to prove anything. It's given that we have two sides congruent. AB corresponds or is congruent to DE. BC, so AB is congruent to DE. That's one given. BC is congruent to EF. And angles are congruent. Angle B is congruent to angle E. All right, and now I have to write my congruent statement. This is really important that I do it in the right order. So I want to follow that same path, 1, 2. So ABC, triangle ABC is congruent to triangle DEF. Okay. All right, so I believe again that these are not in yours. So let's go to some that are. Okay, so this is on page 4. If you want to try page 4 and 5, that's great. It's some basic, like, thinking through some logic proofs. But starting on page 6 is where you're going to start some of your practice of triangle congruence proofs. Okay, so here we give you some information and you fill in the rest. All right, and then some questions about it. All right, so that is what you need to be working on. 7, page 8. So here, I just say prove that, and you want to set up your own 2-column proof. If you prefer a flowchart proof, you can. All right, so these are a bunch of practice. when you are given something, I want you to say, okay, well, AB is congruent to EB. Now, this is a little tricky because there's a mark there. So I would put the mark right on that, just so I know that whole side is congruent to that whole side. And angle A is congruent to angle E. So here I know side angle. Side angle. But there's actually another angle that I know. If you notice, this triangle and this triangle share an angle. This one right here is being shared by both, right? So I know angle, side, angle. Angle, side, angle. So that's my plan. I'm going to prove angle, side, angle. If something is shared, it's the same angle, then we use reflexive property. All right, so I need you to practice, use your properties. All right, and we will practice some more later. All right, notice this right here is the construction marks to make an angle bisector. So you're going to use your angle bisector definition. By definition of angle bisector, I know something about those angles. All right? And if it's the same line, then I know something about that line. CD is really important. They both have that same length because it's the same line. All right, this is a great one. I would like you for you to tell me what A equals. A equals how many degrees? We are going to come in, let's see, on Thursday, and I will give you a little card on Thursday, and you are going to write down what you got for what A equals. So be ready with that. Think about if all of these, what do I know about a triangle that has, okay, what else do I know? There's a triangle, three triangles within a triangle. So use properties of triangles to figure out what is that A. Use logic to figure it out. All right. All right. So I would like you to continue all of this, keep working on this until you get to page 16, and then you can stop. So this is the end that I'm expecting to be finished by Thursday when you come in. Here, I want you to focus on lots of different triangles. So I've got this triangle here, right? What do I know about that? Oh, I have this triangle here that I have two, I already know two angles in this triangle. Right, that says 83, that says 73, so I know this angle must be 180 minus that minus that. All right, and then also I know vertical angles, right? So if I know this is 68, then I know this must be 68 as well. All right, so work through that, figure out what those are. If it's on a straight line, what do you know about two angles that are on a straight line? They are supplementary, so they add up to 180. Good, so we're going to go 180 minus 68 to find what remains there. All right, so work through that, find angles 1 through 6. Thank you for watching. So there was that one page that I asked you to do. It was like 3 flowchart proofs, and also I'm going to ask for the value of A when you come in on Thursday. All right, thanks for watching. Thanks for working. Make sure you finish that whole pages 1 through 16.